Hello dear student, today we will see one of the most important topic in rotation that I had told you that I will make one video and give it to you for the coming exam. So the topic name is finding the moment of inertia of any cavity. You know what is a cavity? You must know the cavity is nothing but when some substance is taken out of a bigger substance, then the remaining part is left with a cavity. Cavity means gap, just like a hole. Okay. So write the name of the topic, finding moment of inertia of any cavity about any point, about a point. Point may be anything. Okay. How a cavity is formed? So it's very interesting. Let us suppose you have a disk of radius capital R, or let us consider the disk is made of radius 2R. Its radius is 2R. And now take out a disk of radius r out of this, like this. Okay, so this will be the center of the disk, which has been cut from the bigger disk. Okay, so actually the real scenario the figure will look like this. This is the center of the smaller disk and this is the center of the bigger disk. This is r and this is 2r. Fine. And the masses are concentrated where? And the masses are concentrated like this. Masses are situated here. Inside the smaller cavity, there is no mass. Inside the smaller disk, no mass is present. Okay, so you can have to find the moment of inertia of this very cavity. Same way, a cavity can be formed like this. Approach is same. The variety of problems can be different. So just focus on the approach. Let us suppose this is an equilateral triangle. This angle 60 degree. Again, this angle is also 60 degree. This angle is also 60 degree. Fine. Some dimensions would be given, like the mass of the whole triangle. The mass of the generally the mass is given of the mass of the whole body. Like what? The mass of the 2r radius disk is given, and that is given to be capital M. Capital M is not the mass of the cavity, rather capital M is the mass of the whole body in which cavity was not done yet. Similarly, capital M may be given as the mass of the whole triangle before cavity was taken out, right? Before doing the cavity, what was the mass of the whole triangle? So that would be given in the question, like it has mass capital M. Otherwise, in some cases, you can get also the mass of the cavity only. So don't be confused. Okay, just see in the question mass of which thing has been given in the question. Is it the mass of the whole body, or it is the mass of the remaining part, you can say, with cavity? This is the mass of the whole body of the radius 2r. Very important this point is, and I am emphasizing this point 2 to 3 times because many a times a student is confused that capital M is the mass of the remaining portion or the mass of the whole body before cavity was taken. Okay, so just read the question. If you read the question well, you can do the question also. Fine. Some question can be also made like this. I will do 1 to 2 question and illustrate the whole process. Let us suppose this is a square of radius A, and here the masses are lying here like this. It means that a maximum circle which would have the diameter equal to 2a, diameter equal to a, radius will be a by 2. So the question can be framed that a bigger a maximum disk, a maximum radius of disk is carved out from a square of edge of side A. The mass of the square plate before cavity was done is given to be capital M. Then find the moment of inertia of the remaining portion. So this can be the format of any question which is pertaining to the cavity problems. Cavity problems are just like these type of sample problems. Then what is the concept to find the moment of inertia of the remaining part? So it's very simple. As we have already seen that in center of mass problems also, we used to visualize the whole body as the remaining body plus cavity. That is the basic concept here. Let us suppose the disk of radius 2r is actually equal to the remaining portion with cavity plus this very cavity with mass, something like this. When you insert this very smaller disk into this, when you fit this smaller disk into this, into the cavity, you will get the bigger disk, right? So moment of inertia, let us suppose you have to find the moment of inertia. The question is like that, you have to find the moment of inertia about the point O. So just demarcate your point O in every figure. Okay, in each and every figure, just demarcate your point O like this. So here point O will be like this. Fine. So you can see the moment of inertia of the whole body about point O is a very basic formula. Why? Because you know that when you have a disk, when you have a disk of radius r and mass capital M, then its moment of inertia about the center of mass is mr square by 2. Isn't it? ICM is equal to mr square by 2. So I of whole body, I of whole body, I of the whole part about the point O. You can write this statement, very important statement. I of bigger disk about O is equal to what? I of remaining about O plus I of cavity about O. This would be the strategy. This strategy is followed in solving any question which is pertaining to your cavity, right? So mass of the radius is given to be here. The radius is given to be here 2r, and the mass is capital M. So what is the I of bigger disk about point O? O is the point. We have demarcated the point O as the point about which you have to find the moment of inertia of the remainder. This is the remaining part when cavity is carved out of the bigger body, right? So I of this untouched body, when cavity was not actually extracted, hole was not done. So before drilling, or you can say that before carving, you have you had actually this much surface, and this was a complete bigger disk of mass m, radius 2r. So I of bigger disk about o will can be found out using this very formula. So what you can write, you can just write here, you can just write here as mass is m, mass is here m, half mass is m, and radius is 2r. So 2r square. Okay. You have to find this I remaining about O. So let us suppose this is equal to, for the time being, this is equal to x. Okay. So just you have to solve a linear equation like that. X. Okay. Plus what you will write? I of cavity about point O. I of cavity about point O. This is a very important question now. I of cavity about point O. Now the cavity has a center of mass here. The cavity has a center of mass here. What is the mass of this very cavity? So mass of this very cavity can be found as m is equal to sigma into A. Right? Sigma is nothing but total mass by total area, and total area is pi into 2r whole square. And area of this cavity will be what? Pi into r square. So from here pi and pi will be cancelled out, r square will be cancelled out, so it will be equal to m by 4, isn't it? Radius is halved, so area will be 1/4, hence mass will be also 1/4. If uniform mass density is given, and I am assuming that uniform mass density is here. So the mass of the smaller disk is now m by 4. So now what you have to do? You have to first calculate the moment of inertia of this very smaller disk about its center of mass. About, not about O. First calculate the moment of inertia of the smaller disk about its center of mass. Let it be, this be the axis. And then apply the parallel axis theorem. Parallel axis theorem says that whenever you have a center of mass, let us suppose this is the center of mass, and this is the point, and this is ICM, and this is IOO dash, then IOO dash is equal to ICM plus MD square, where D is the separation between the two axes, isn't it? I have explained many times in the class. So this is the whole funda that I have to utilize here. So here I will have to write what? Half times 1 by 2 times moment of inertia of this smaller disk about its center of mass. It will be equal to half times m r square, and m is equal to m by 4 into r will be equal to r, so r square plus md square, means what? M by 4 into d square, and d is equal to r. Okay, isn't it? This is the golden approach. This is the actual approach you will have to follow in every question while solving the cavity problem. I mean to say this. Now you have to just solve. How you will solve here? 4 is cancelled by 2 as 2. So 2mr square will come out here is equal to x plus m by 8 r square plus m by 4 r square. Okay. So you can find the value of x from this very equation. You can get the value of x from this very equation, and that will be your answer. That will be your complete answer. Whatever will be the value of x, that will be the value of I remaining about the point O. So I am just revisiting all things once again, that if you have to find the moment of inertia of any cavity, then first in the question see that mass is given of which thing, of the initial structure or of the remainder structure or the remaining structure in which cavity is lying. Most of the cases, in 99% cases, mass will be given of the original body. If mass would be given of this very body, then complexity may arise. You will have to find the ratio of area, and then by unitary method you can find the area of this thing. Okay, how can you do that? Let us suppose mass is given to be, mass m is given to be of this very body. Huh? Then how you will utilize the problem? How you will solve this very problem? So this whole body was actually equal to this plus this. Let us suppose it has the mass capital M. So first see that it has a radius 2r. So it has the area 4 pi r square. Okay, pi into 2r square, 4 pi r square. It has the area r, so it has radius r, so its area will be pi r square. So its area will be 3 pi r square. Okay. So by unitary method you can find that. So its ratio of area will be A1 is to A2 is to A3 would be 4 is to 3 is to 1. So accordingly you can find the mass of this thing also and this thing also. Okay, this has the mass 3 times. Okay, so if this has the mass m and area is 3 times as that of the smaller cavity, so its mass will be equal to m by 3, and its mass will be equal to what? 4 by 3 m. Huh? Isn't it? 4 is to 3 is to, this is m by 3, this is 4 by 3. So 4 by 3, you when you add this 4 by 3 m is equal to m plus m by 3, the equation is also satisfied. So hence the mass will be equal to this much. Okay, why? Because mass is proportional to area in the uniform mass distribution case. So in the question, while solving the question, you must have to see that mass of which thing has been given in the question. Is it the mass of the whole body or the cavity problem? Okay, in some question you may be confused by, just I will give the mass of the cavity, mass of the, not cavity, cavity is actually this is called cavity. This is what? Cavity. And this is called remainder part, remaining part you can say, and this is the original one, this is the original one. Fine. So this is the crux of the question. How to solve? I of the whole thing about O is equal to I of the remainder about O, and I of this thing about O. I of the whole thing about O is the actually the center of mass of the this very original disk. So this is equal to mr square by 2. Hence I have directly written half mr square. R is equal to 2r. I have to find this thing. So I need not have to find the mass of this thing explicitly. Why? Because it will be automatically calculated. Once you will subtract this thing from this thing, you can get the answer. Now, the mass of this thing has to be calculated, and you can see that here radius is 2r, here radius is r, here the radius is r, so area is 4 times as that, so mass will be also m by 4. So m by 4, half m by 4 r square is the moment of inertia of the smaller disk about its center of mass, and when you add m into r square, md square, you apply actually the parallel axis theorem. What you are applying here? Parallel axis theorem. Okay, you have to find about this. You know about this. So apply the parallel axis theorem. You can get the moment of inertia of this cavity about 0.0, and when you subtract this thing, you can find the value of x. Calculate the value of x. Fine. This is the whole funda. Very easy. The person who knows how to calculate the moment of inertia of any body, he or she can also calculate the moment of inertia of the cavity type problems. The whole problematic situation arises due to the not knowing the method of finding the standard method of finding the moment of inertia of standard bodies and the bodies which are made up of the standard bodies. You will have to learn the moment of inertia of rod, about center, about the end point, moment of inertia of a sheet, moment of inertia of a disk, of a sphere, and all those things. All those standard formula that I have taught you in the class only. Okay. So we have done this very problem. Now this problem can also be done using the same formula. Okay. Let us suppose you have this problem. This is the part remaining part when you carve out a circular disc of maximum radius out of a square plate. Square plate has the side A. So how to solve this very thing? And let us suppose let m be the mass of the bigger square. Original square you can write. You can write original square. Okay. How can we solve this? Just think like this. Okay. You have to find the moment of inertia of the whole thing about, let us suppose we have the point, this very point O. Fine. So this is very simple question. About this very point O, you can find everything. It is very simple. Why this is very simple? I am saying, why I am reiterating it. It is very simple. Because you know the moment of inertia of the whole plate about point O. I have taught you in the class that whenever you have a rectangular sheet, then its moment of inertia about its center is m by 12 a square plus b square. So if a is equal to b is equal to a, so m by 12 into 2a square m, m by 6a square, it will be the answer. It will be equal to, you can write also, I of original about O is equal to I of remaining about O plus I of cavity about O. It is as simple as this one. I of original about O is m by 12 times a square plus a square, isn't it? What is the I of remainder about point O? Let us suppose this is x. Khatam. I of cavity about O. I of cavity about O. So cavity is a circular disc, and of a circular disc, you know the formula that it's ICM about its center of mass. O is fortunately the center of mass. It may not be the case also. If the question would be find the moment of inertia about this very point, then everything would have been changed. But you can write the point P, you can write the point P, you can write the point P here. Replace O with P. Okay, I can discuss that very thing also. So this is x plus cavity. This one is the cavity. What is the area of this very cavity? Pi times a by 2 whole square, means pi a square by 4. Okay, so that mass would be, the mass of cavity would be sigma into area of cavity. Sigma is what? M by a square, isn't it? Into what is the area of cavity? Pi a square by 4. So its mass will be pi m pi by 4. Okay, here is also pi. Sigma is pi. No, this is a square. Area of a square is a square. M by a square will be the sigma into area of cavity. A is the area of cavity. When you are finding the mass of the cavity, you will have to put the area of the cavity also. Area of cavity will be equal to pi a square by 4. Why? Cavity has a radius a by 2. This whole part is a. Right? Accordingly, you can find the mass of the cavity as pi m by 4. So pi m by 4 half times itna into a by 2 whole square. Now you can subtract this thing from this thing and you get the answer. Life may not be so simple as this question. In some questions, you may have to find the moment of an inertia. Let us suppose I shift the point. I shift the point like this. This very thing is this plus this. I will just write the expression here. Let us suppose this is A. Okay. Let us suppose I have to find the moment of inertia about this very point. Which point? This point. This is the point P. This is the point P. And this is the point P. Where is the point P? So you can draw like this one. Okay, so point P is here. If you have to find the moment of inertia of this thing, point P, about the point P, everything is rotating, right? Approach will be same. Approach will be same. There is no change in the approach. When you are changing the approach in every question, it means that your concept is not clear. Approach should be a standard approach that can be applied in any problem, whether it is from JEE or NEET. So whatever concept I am discussing today is applicable to both the aspirants, JEE aspirants as well as NEET students. Okay. So this is the case. So can you find it, find now the moment of inertia? Moment of inertia of this very thing about point O would be what? Moment of inertia about point O would be m by 12 a square plus a square. About this very point, you know, about the point O, you know the thing, you know the formula. So about this very point, this would be distance d, and what would be the value of d? 2d will be equal to a square plus a square root 2a. So d will be equal to what? A by root 2 plus m into a by root 2 whole square. I have applied what? Parallel axis theorem here. Parallel axis theorem. Okay. Moment of inertia of this has been found as the formula of moment of inertia of this thing, the whole body about point O, isn't it? Now, the moment of inertia of this remainder has to be x about the point O. So, moment of inertia of this thing about point O would be what? Let us suppose its mass is m dash. And m dash I have calculated in the last question. It was coming out to be m pi by 4. So, I will have to write half times m pi by 4 times r square. R is equal to a by 2 whole square, half mr square, plus I have to add md square, and d will be equal to what? This much distance will be the d. Okay. So d value is a by root 2. So I will have to write a by root 2 whole square. Again, parallel axis theorem we have applied. So two things are there. Two things are there which has to be minutely observed while doing the question of this very topic. First thing is mass of which thing is given. Mass of original oblique remaining given in question. Observation. First we will observe mass of original or remaining body is given in question. Second observation is that about which point, must write down these all these things in your copy separately. About which point we have to find moment of inertia. Observe very smartly. Alertness के साथ आपको देखना होगा. You will have to see all these things with utmost alertness. The person who is alert, the person who is disciplined, the person who is confident on his or her studies also can do this type of problem very easily. Nothing is problematic in this type of questions. You can solve very happily. But the person who are very anxious, the person who doesn't take the things very seriously, in other words, I can say that they things very lightly, will feel difficulty in solving these type of problems. Because I have thousand times told you guys that rotation topic is not a impossible topic. If you pay attention from the very first class, this topic will be a very enjoyable journey with respect to the other topics of the physics. In other topics, you have 2 to 3 concepts. But in rotation, you have 10 to 12 concepts just running into your head. And which concept will be utilized at which place, you never know. So better alert in the class. Be alert in the class while I am teaching. While I am delivering a lecture, write each and every point. That will make the difference. And believe me, if you will follow that strategy in the coming 5 to 10 lessons or chapters, you can do wonders. Okay. So this was the whole technique, whole concept, how to solve this type of problems. So I have done this problem, I have done this problem also. So similarly, you can try this question. This question you can try and show it to me whenever I come to school and I teach you in the class. Okay. So this is also the side A, and this is the equilateral triangle. So every side will be equal to A. So you have to find the moment of inertia about this very point. How can you find? Just try it. Try to solve it. Okay. So I have committed you that I would give one video. I will before your examination is done. So I was thinking that this topic was very important, and I skipped this topic during the class. I actually don't know why it has been done. So again, I am saying that this topic is very important, and try to understand the concept of this very topic and whatever things I have told you. This is the only topic that we had left. Otherwise, we have done up till angular momentum very smoothly. No topic has been left. And all the best for your examinations. Do the questions very patiently. Feel confidence in yourself. Feel confidence in whatever you are studying. Don't be panic, because alertness will make you think a difficult question also. When you are alert, you can think more on a difficult question. But if you are not alert, if you are not attentive, if you read the question very fast, some data would be missed. You can take that about this point, the question is asking about this point. You may assume this and solve and calculate the answer about this point. And after the examination, when you check your answers, you commit, you actually tell yourself that you have committed a silly mistake. So doing the things very quickly, very fast is not so good always, because you don't have to solve 100% of questions in JE. Especially I'm telling for JE guys. For JE, if you solve 70 to 80%, you will be among top 100. And for NEET people, the questions levels are not so hard. You can crack each and every question. Okay. So on this note, I'm signing off. So meet you guys in the school. All the best for your examination. Thank you.